Hey everybody, how's it going? All right, so today we're going to be talking about the TI nspire CX CAS. I've got the CX CAS 1 here in my hand. The software that we'll be using is emulating the TI nspire CX CAS 2. And the goal of this video series is to start addressing some of the higher level concerns and uses for this calculator. Today's video is going to be largely introductory, so if you already are pretty confident with the nspire, just turn this up to double speed and watch it. It's really important that you and I are working on the same assumptions of what kind of variables to use and how we're going to assign our variables and all of that, so that when we get into the programming and a bit more of the engineering uses for the calculator, that we're working with the same foundation. If you're new to the nspire, hopefully that this will act as a way for you to start using this for some base level applications or high school applications, etc. So when you turn on your calculator, you're going to see this screen. That one, this screen right here, okay? Just don't use the scratch pad. This right here, don't use it. I don't like it. I don't want you to like it. The scratch pad has all sorts of issues. Yes, it's convenient, it's fast, but you'll run into a lot of problems here with variables and just junk. So for all of our videos, we're going to be working inside of a document. Okay, so if we open up a new document, this is the screen you'll see. Today we're going to be sticking in the calculator section. As we go forward, we're going to spend a lot more of our time here in the program editor. Okay. So the biggest defining characteristic of the nspire CX CAS is that CAS part, that it is a computer algebra system. All right. So that means that the calculator can recognize variables and will treat them as variables and not just as letters, right? It can do algebra, right? So this means if we typed a plus b into our calculator, it would keep it as a plus b because we haven't assigned values for a or b. So that's all it can do. That's all it can say. Okay? So how do you assign variables? There's two methods to assign global variables. And you've got to be careful when using global variables because they're global, which means they'll stick around from page to page. But I prefer working with them, and so that's what we're going to do. So if we want to assign the letter A with the value 5, we would type A, and then you're going to go Control right here, this button. It's colon equals, okay? A colon equals 5. This will set A globally equal to the number 5. So if you type A, it's going to come up bold, which means it has an associated value, and that's going to be 5. If we do A plus B, only A has a variable assignment, so it's going to just give you B plus 5. Your calculator defaults to alphanumeric and alphabetical order. So if we had typed C plus B, it's going to change that to B plus C to put things in alphabetical order, okay? Still equivalent. It's gonna do the math right. Don't worry. Addition is a commutative property, so B plus C equals C plus B, but it will put it in alphabetical order. All right. So we've got A assigned to the number 5. Let me scoot over here for a bit. And B is still unassigned. But if we assign B, we can use that same method to assign B to the number 3. And then if we now do A plus B, it's going to give us 8. Note that AB is not bold. This is not A times B. A lot of times we have a bad habit. I had a bad habit when we do handwritten arithmetic of using implicit multiplication, where we just smush the letters together and we say, oh, this is obviously A times B. You've got to break that habit with the calculator. You can use parentheses. Oh, this is not a function of B. Don't use parentheses either. Just use explicit multiplication. Okay, you've got to. We'll talk about functions later and how to take the derivatives of functions and kind of their purposes. But when you're doing multivariable or you're doing interactions with variables, make sure your multiplication is explicit. This is because the calculator allows you to use multiple letters for a variable. So we could use AB as its own variable of 100, okay? Or we could use Preston as a variable, as 5, right? Note that the calculator is not case sensitive. It'll take lowercase Preston or uppercase Preston as the same variable. You can also store things as a variable. So let's say you did some crazy stuff, and so you have a wacky number. So you have, let's say, pi times 5 divided by 2.0. So you've got this number that is, irrational, and you want to assign it to a new variable. What you're going to do is you're going to grab that number and then store right there, right? Control store into a variable. So now f has been assigned that value of 7.853916, etc., etc. Okay? So these are two different ways to assign global variables. Once your variables have associated numeric values, at some point you'll want to clear those values. You'll want to delete them. Similar to most programming languages, you can use clear AZ to delete all of the purely alphabetic variables. This is only 26 variables. So note that AB, which is not a single letter of the alphabet, is still assigned a value. Same thing with Preston, still has a value. To get rid of those individual variables, you'll have to use del var, which is delete variable on each of those. For this reason, I encourage y'all as we go forward in this series to use strictly alphabetical variables, okay? When we're writing our programs, we might use phrases, words, Greek letters for display purposes. But for the actual code itself, you'll find that we always use single letter variables because that way we can just put clear AZ and we don't have any mistakes. It is important to note that with global variables, let's pick the letter X, okay? If we set X equal to 2, that's true in this page of the document. If we create a new page, X is still equal to 2, okay? It's global. And you can overwrite them. So if you tell the computer, no, X is actually equal to 3, now X is equal to 3 everywhere, okay? Again, it doesn't matter if I type clear AZ in all caps or in all lowercase or in some weird dumb case convention, okay? It will always correct it and just take the non-case sensitive code. So now you know how to assign variables and how to delete variables. Next, we're going to talk about how to get the calculator to do simple algebraic solving using variables. So if you need a function that's built into the calculator and you know it, like solve, you can just type it in, okay? But let's say you're one of my newer users to the TI nspire, you're not that familiar with the functions that it has built in, you can go right here to this book, okay? And when you click that book, I'm already there, but you just type the letter S, scroll down to solve. There we go. Okay, and you can double click it. And now solve is there. So solve all by itself is a single variable algebraic solver. So if you had something like b plus 5, let's throw that in parentheses, divided by 2.0 equals 7, and then tell it to solve for b, it'll tell you that here b equals 9. Okay? Something to note here, if we, let's take this and make it not a whole number. Okay? It gives it to us as a fraction. If we put it in as a fraction, it'll put it out as a fraction. If we put it in as a decimal, it'll put it out as a decimal. Okay, it's going to match whatever numeric format that you give it. All right, so if we instead did this with 2/3 as 0.66, it's going to give it out. Or if we had done 2/3 here and 5.0 here, it's going to give it to us as a decimal. Okay? The reason it does this is because you've given it a number of you've put in floats. As soon as you put in a float, it's going to put out a float. All right? If you keep everything with integers, it'll put out integers. It'll do it in fractions. Whatever it needs to do to keep the integers, it'll keep them. All right? This is typically not a big deal, but I have seen a lot of people using the Control-Enter to try and get that fraction gone. So if you have 1/3, you can hit Control-Enter, and it'll give you the approximate answer. But if you're just careful about how you type things in, it'll give you the answer in the format that you want every time without having to do extra keystrokes. Okay? All right. So that's the single variable solve function. It's very simple, sometimes useful. Typically, once we're down to a single variable problem, it's probably just as fast to do it by hand. The nspire is also able to do multivariable algebraic solving. So I know in the past, calculators like the TI-84, TI-84 Plus are able to do matrix math as long as it's non-algebraic. But we can do algebraic math here as well. Okay, so if you had this equal to C, it's going to tell you that B is equal to 2/3 of C minus 5, right? And this is really what's unique about the CAS. It can do, it can find solutions algebraically, and it can plot those out. All right, so this doesn't need to have numbers. This could have had just purely algebraic expression. All right. You'll see me a lot throughout this series going up and grabbing numbers. It's pretty easy. You just scroll up and hit enter if you want to grab that side. If you only want a portion, use the side arrows to navigate. Hold down the shift key and then type the sideways. Okay? And that'll let you grab a portion of an expression or an argument. You can also go up and use copy paste just like on your computer. Hold down shift and then control. We'll do it on the keyboard so you can see. Control copy down here, control paste. Okay, just like on your computer. You can also use control cut. It's not going to do anything here, but it should paste still, right? It's not going to cut because this is already finished, but we could probably cut from this, control cut, see, and then control paste. All right. Cool. All right, so multivariable solving. You go here, it's next to solve, and it's solve system. If this is your first time, you need to turn your wizards on. Once you check this checkbox, it'll stay marked for the foreseeable future in this document. We'll talk about that in a little bit. But you need to keep those wizards on. The wizards is this pop-up box right here. So when you start doing your solve system of equations, it shows you these options. So we're going to do two variables, and we're going to do A and B. And let's see, for our equations, we'll do A plus B equals 7. And we'll do A equals 3, right? And this is a really obvious one where B is going to be 4, A has to be 3. But this can get infinitely complicated. The calculator will almost always be able to solve these all by itself. There have been a couple times in three-dimensional dynamics where it's run out of memory or RAM before it's been able to solve the equations. But typically, if it takes you less than 20 minutes to type in the equations, the calculator will be able to solve it no problem. These do not have to be linear equations. So if we did this and we said that, let's say the sine of A equals 3, it's going to tell us that's false. Sine of A equals 3. There you go. So if we did the sine of A, you can't make a sine function equal to 3. Sorry about that. But if you did the sign of a equal to 0, right, you're going to have any value of a that's some multiple of pi, right, is going to make sign equal to 0, and then b is going to end up being this chunk right here. Okay. All right. So that's multiple variable solving, single variable solving, variable assignment, deleting variable assignments. The last thing we're going to talk about in this video is how to tell the calculator to evaluate. So if you had an equation like a, we'll just keep it very simple for now, a plus b equals 7, and you wanted to say, okay, that equation, but evaluated where a equals 3, right? You could do control equals, is this evaluated bar, where a equals 3. And now it's gonna plug in a equals 3. This does not assign a variable. This can be really, really useful as we get more into the calculus in the next video of how to use this calculator to do complex multivariable calculus. When it spits out a large chunk of algebraic mess from, say, an integral, and you want to evaluate that integral at 0, or you want to evaluate that integral at t equals 5, you can simply say control equal evaluated at t equals 5. And then whatever answer you had, whatever was put out by the calculus, will then be evaluated at t equals 5. Okay. Hopefully this is enough to get y'all started on the Inspire. This is going to get you instantly through most of like 9th and 10th grade math. In the next video, we'll be going through calculus really quick using the integral and derivative functions, doing explicit and implicit derivations. We'll be doing time derivatives, spatial derivatives, explicit integrals, definite integrals, and undefined integrals. So should be pretty chill. All right. Thanks, guys.